Hello everybody, good afternoon. We are the team number 9 and my team is composed by
Emiliano Treviño Venegas, roll number 41.
Mario Alberto Estes Martinez, roll number 42.
David Alejandro Velasco Leza, roll number 43.
and me, that I am Regina Zavala Villalpando, roll number 44. In this video we are going to talk about all the topics that we saw on the semester in the subject of physics selected topics.
We hope that this video helped you to understand better the topics. In the stage 1, we learn about the fluids, and also we see concepts like density, pressure, and principles like Pascal and Archimedes. But in this video, I'm going to focus on the pressure, and it is defined like this force over the surface, and its unit is the Pascal. We can see applications of pressure in our daily life because it is present in gas distribution networks, in drainage system, and in water distribution system in our house. An example of this could be the next one. Okay, in this situation we have a pipeline with a radius of 0.045 meters and the water that flows with a force of 800 newtons. So to calculate the pressure of this pipeline we need the formula of pressure, that is force over area. The first thing that we need to do is to calculate the area, that it will be radius to the square multiplied by P. And the result will be 6.36 multiplied by 10 to the minus 3. Then we're going to divide the force over the area. The result will be 125,752.05 pascals.
During the stage 2 of physics, the topics that we saw were the thermal equilibrium, the kinetic molecular theory, the measurements of the temperature, like Kelvin, Celsius, and Fahrenheit, the thermal expansion, the specific heat of many objects and substances, the heat transmission, the combustion of the objects, and the laws of thermodynamics. Some of the applications about all these topics are the heat sources in the house, like the boiler or something like that, the environmental and cooling in buildings like the air conditioner, the heat exchanging devices, like some of them are examples of parts of the cars, and the atmospheric phenomenon. Well, for the problem, we're going to explain how much heat transfers the engine of an automobile to 12 liters of water contained in the cooling system of the same if the temperature of the water rises from 15 Celsius degrees to 95 Celsius degrees. First of all, we have all here the data that we're going to convert into the international system units that are meter cubic Kelvin, and we have the density of water and the specific heat of water. Then we're going to use this formula to obtain the mass of the water that's going to be heated. We have here that mass equals the density times the volume of the water. That is going to be 12 kilograms. Then this formula of the temperature is final temperature minus initial temperature, and here we have that is going to be 368 Kelvin minus 288 Kelvin, and it's going to be a total of 80 Kelvin degrees. Then finally, to obtain the heat that is going to be needed, we need to use this formula, that is mass times specific heat times the temperature. And here we have the data that is going to be 12 kilograms times the specific heat of water, that is 4186 joules over kilograms and Kelvin, and times the temperature, that is 80 Kelvin. So finally, after multiplying all this, we got that the result is going to be 4018.6 56 joules. And it's
Okay, hello. I am going to explain all the topics that we saw on the stage 3. On this stage 3, we talk about electricity, and some forms of electricity are, for example, the electric charges, the Columbus law, the Ohm's law, and specifically I am going to talk about the electric circuit. The electric circuit is when it passes the energy through a conductor and then in return to the system. We have 4 different types of electric circuit. Well, the first circuit is the simple circuit that is based on a switch, on the resistor and the source, and of course wires. The second circuit is the one that's series. We have resistors that are attached one to another, like we can see. Another type of circuit is the parallel, which the resistors are attached to the source. And we have the last circuit that is the mixed circuit, that it is mixed or it is composed by the parallel and the series circuit. Some devices that are used to measure, for example, the electric current is the ammeter, the voltage is the voltmeter, and the resistance of these electric circuits is called the ohmmeter. Some applications that it is used when you have electric circuits are, for example, in your house, when you connect the TV, when you use a microwave, when you use a refrigerator, and all these types in your house have electric circuit. In all our daily life, we use the electric circuit. I am going to explain you a problem using the mixed circuit that we have here. We have the data that the resistant one, it has a value of 150 ohms. The resistant 2, that is 200 ohms, and the resistant 3, that is 100 ohms. Here we have to calculate the total resistance of this circuit. So the formula that we have is total resistance is equal to resistance 1 plus resistance 2 plus the quantity that we have of all the resistance. And also we have this formula that it is total resistance equals to 1 over resistance 1 plus 1 over resistance 2. The procedure that we have is that we are going to add these two resistance that are here because are in series. So we need to add them. And then we are going to use this another formula. And the total resistance equals 1 over 150, then plus 1 over 300. And the result of this formula is 100 ohms.
During the stage 4, we saw different topics about oscillations and waves, optics and sound. Acoustic is the science that studies the sound that is produced by a source of vibration. The sound is transmitted by longitudinal and transverse waves. To produce a sound wave is required a soft in vibration and elastic medium. The speed of sound is greater in solids and liquids, and lower in gases. In air, sound travels at 333 meters per second at 0 Celsius degrees. When increasing the temperature of the air, also the speed of sound increases in 0.6 meters per second. For each Celsius degree, some applications of it are calculate the speed of sound in different temperatures, identify the sound source, and measure the sound transmission. Well, in this problem, we are going to calculate the speed of sound in air at temperature of 20 Celsius degrees. Well, first, we know the data that the velocity of the sound in the air are 330 meters per second, and the temperature is of 20 Celsius degrees. Well, to calculate this, we are going to use the formula of speed equals to 330 meters per second plus 0.6 meters over seconds over Celsius degree times the temperature. Then we substitute the data and the formula, and we have the 330 meters over seconds plus 0.6 times the temperature, that is 20 Celsius degrees, and that is 330 meters over seconds plus 12 meters over seconds, and the result is 342 meters over seconds.
With this video, we can understand better the topics, and the topics that were more difficult now became clear. So now we can feel prepared for the global exam.
And also now we know more about the uses and application of these topics in our daily life. We hope that this video was very helpful for you.